Watch Mr. Wizard. That's what all the kids in the neighborhood call him because that's what he shows them the magic and mystery of science and everyday living.
Mr. Wizard?
Oh, hi, Alan. Come on in.
Hi, Mr. Wizard.
Hi.
What's that?
Well, this is my APP,
APP.
automatic pea packer.
Oh, gee.
Those are supposed to be peas, you see, and I'm packing them here in that slot. And as you can see, they run down here and start over. So I have an inexhaustible supply of peas to pack.
That's clever.
Well, thank you. And I hope before you're through today that you're going to be able to understand how an engineer would solve problems, because that's what you're going to be today, is an engineer.
An engineer?
Yes, and I'm going to throw problems at you, very similar to what an engineer gets, and see if you can solve them.
All right.
And they're all going to be the same problem, over and over and over.
Well, if I solve it once, then what's the sense?
Well, you have to use 6 different ways of doing it, or 5 or 4, however many you can dream of. Come over here. You stand right there.
Okay, I'm right here.
And here's your problem. Back here is a motor behind this board. See? And if I turn it on, see that shaft going around?
Yeah, it's going around. In a circle.
Well, now, motors have shafts that go around, right?
Yeah.
And motors are the sort of powering device for many modern machines. So that's the starting point, this round motion going round and round. That's what you have to start with. But I don't want something to go round and round. As an engineer, I want you to do this. See this piece up here?
Yeah.
I want it to go up and down like that.
That's simple enough.
Huh?
Yeah.
Okay, well now, as an engineer, that's the problem you're going to have to solve, and you're going to have to solve it 5 different ways. Aha.
5?
Yes.
I
You have an
only know
idea?
of one.
You have an idea already? What?
A piston. Use a piston.
Okay, that's kind of the standard one I think most people would think of, and that's the wheel. Now you see, I can stop this and put this wheel on here by tightening that screw. So I'll push this back like that and put that here like this, and put that wheel on. Now what do you want?
Now I need a rod that I can fasten onto this wheel and onto this.
Will that do it?
Yeah, I imagine so.
Okay.
That's it.
Now you see,
It has to be loose.
I have all kinds of wing nuts and bolts and things down there. So you take one of those. That'll fit on like that. I've already got one of those on here. You just put that on like that, and I'll put this one on up here like that, and then you put a wing nut over the top. You get the idea how we're going to solve? Now you have to solve this same problem now, as I said, 5 times. Your first one is, what do you call this?
Piston.
A piston. And connecting rod.
And connecting rod.
Which is which now?
Well, this is the connecting rod.
That's the connecting rod. This is the piston, right? And this is the wheel.
Right.
Okay, now, when I turn it on, do you think that's going to work?
Should.
Well, you tell me why.
Well, because it's loose, you see. So when this goes up, it pushes this rod up. And that pushes this, and then when it goes down, it pulls down on that.
In other words, the reason why you're getting up and down motion is because there is a component of this motion that is up and down. It's down the bottom here, and then it's up here, and you're getting rid of the sideways motion by having this loose, right? Well, very good. That's the first solution.
That's one.
And let's see if it'll really work. Aha, very good.
Yeah. Works quite well.
Congratulations.
Thank you.
Pretty clever, as you said to me.
We just lost something here.
Those are little spacers I have up there. Now, where do you know of a place where they use this piston thing to get circular motion into straight up and down?
In a car.
All right, come on around over here. I have a sort of wooden version of one. See it over here?
Yeah.
Down below here is a rod that goes around and around, see? And that's the circular motion, and where's the straight up and down?
Over here.
Okay, now what are these various parts represented in a car?
Well, this is the shaft.
Yes, that's the crankshaft.
That's the crankshaft.
Okay, yes.
This is the connecting rod.
Right.
It connects the shaft.
All these rods. Yeah.
And this is the piston.
Okay. Now let me explain what happens when you first start the car. When you put your foot on the starter, the starter is connected to this crankshaft. It's an electric motor. Battery current makes the motor turn around. Of course, it goes around. And that this crankshaft then, and the connecting rod, make the piston go up and down. So you go from circular to straight line motion. Now what happens when gas and air is fed in here and the spark plugs fire? You tell me what happens.
Well, an explosion occurs.
Then what?
And that sets that pushes down on this.
Yes.
And it turns this, and this is connected to the wheels.
Okay, so you go just the reverse then. You go up a straight line motion, finally turns into a circular motion. Okay, very good. All right. So that's the one I think most people would think of, but here's one which you probably have never had any chance to use. It's in a little machine called a nibbler.
Nibbler?
A nibbler. You know what a nibbler is?
Sounds like a person who eats a lot. Or nibbles a lot.
Nibbles, yeah. And that means to take a series of little bites, doesn't it?
Mm-hmm.
Well, that's what this is. This is a machine that takes a series of little bites. Now, I have it here on a control so we can control the speed. I'll make it go very slow first. And you see, first of all, here is a motor with a shaft that comes up here like this. And you can see the end shaft. I put a piece of plastic over here so this part wouldn't come off. You can see the round section over there?
Yeah, that's the end of the shaft.
Take my pencil so you don't get your finger stuck in there.
Yeah, right in there is the end of the shaft.
That's it. Well,
and that's going around in a circle.
Right underneath there is the center of it. Okay.
That's what I mean. Now, down here is the connecting rod.
Mm-hmm.
And it just like the model I made, it goes around, and then this connecting rod is attached to the piston.
Which is right there,
Yeah, this part, and that's going up and down.
Okay. Now, you can watch. See at high speed?
Uh-huh. Nice breeze.
Now, right in here is a very hard piece of steel, and as this goes up and down like that, see how this moves in and out?
Yeah.
Okay, that's the part that's going to do the nibbling. Now here's a piece of sheet metal. You feel that? It's a pretty substantial hunk of sheet metal.
Yeah.
I'll hold this up here like this, and you put that piece of sheet metal right in there like that.
Okay.
And I'll start slowly first, and then I'll pick up speed, and you watch how it nibbles a section right out. Okay?
Yeah. Right up. It's pretty good.
And here are the little pieces that we nibbled out, see?
Uh-huh.
And so this is a machine that is used now to take that circular motion and make it go up, straight and down motion so we can cut out little chunks of thing.
It's very handy.
Very handy. So as an engineer, you would design machines that would do that. Circular to up and down motion by the first system, and we're going to call that what? Piston and crankshaft.
And crankshaft.
Okay. Next problem.
Now we have to think of what? 4 more ones.
Yeah. What's the next method? I kind of figured maybe you'd have trouble from here on.
Yeah.
So what I've done is I'll show you the parts that I've made to do it, and you see if you can at least put them together, and that way get an idea.
Okay.
You take that
This one?
the connecting rod off.
It's off.
That's all. Here's the new part.
Well, obviously, this is going to attach to one of these.
Same place they did before. Okay, all right. I'll do that. Anything else you'd like to do now? You like that, you mean?
Yeah.
Okay, I'll just put one of those up there. Now, what else do you suggest?
Well,
All right, one is enough, I think.
okay.
Now what?
I think this will have to...
Go over on that?
Yeah.
Wait a minute. Before you do that, put another spacer on and lift it out like that. And go like that, you think? Okay,
Yeah,
now take one of those wing nuts and put it on. Now, see if this will give you circular motion into straight line.
Now, this should go, when this starts turning, it'll have to move along this track. And when it moves along this track, it's going to build up pressure along here. It's going to push it up.
Okay, let me turn it on slowly and see if that's true.
I hope. I'm right.
Congratulations, you
Thank
solved
you.
the next one. Now we'll call this one the slotted yoke.
Slotted yoke.
Yes, but this is a slot, and this is could be called a yoke. So for our purposes, we'll call it a slotted yoke.
Okay.
There, you see that? Very good. Now, how is this different than the connecting rod?
Well, this is, in the piston, the connecting rod was moving.
Well, it was flexible.
Yeah, flexible. In this case, it's not flexible. It's very...
We shouldn't say flexible. We should say can pivot. In this case, it doesn't pivot, and that sideways motion is taken up with the slot. Well, come on over here. I'll show you a machine that uses that, because I don't think you probably have ever seen a machine that uses this kind of a thing. But here it is right here. Here, come on over here so I can show it to you. Let me take it apart first. Here's motor, shaft, little gear down here, and a big gear. Now, keep your fingers out there. I'll turn it on. See the shaft going around?
Yeah.
See, here's the shaft from the motor right here. Turning that gear. And here's a pin. Now, we've got to put a slotted something on that pin, don't we?
Yeah, just like we did over there.
Okay, now look here. Here's as a saber saw. See, the saw has a slot in it here?
Mm-hmm.
If I put that slot right down like that, I have to put these two collars on. See, I've taken these apart so we could see it better, and they really are meant to have a top on it so they can't come out this way. Now let me slowly turn it on and see if you can. Okay, now you see the. Here, take my pencil again so you don't get your fingers. Now show me where the.
Here's the slotted yoke right here,
right.
And here's that part that it goes over with the sideways motion.
Mm-hmm.
And it's pushing that back and forth.
Right now, and so therefore you get a saw-like motion. You see that?
Mm-hmm.
Now, why would an engineer design this rather than a piston and connecting rod?
Well, maybe there's not enough room for a piston.
Well, you see, if he was going to have a connecting rod, it would have to, perhaps go down beyond this and whatnot. And this is one of the things that determines whether an engineer uses one system or another. It would depend on the cost and how difficult it would be to make and so forth.
This is
slotted yoke.
Slotted yoke.
That's number 2. Okay, number 3 coming up. Can you think of anything? Meanwhile, let's take this off.
No.
I'll give you another clue. This comes off.
It's off.
That comes off. Also, this wheel comes off.
Does?
Yeah, so I'll loosen it in the back and you pull it out. Okay?
It just missed my fingers.
Oh, it did. Here's the next clue.
This.
Yes.
Well,
Now,
obviously, this has to go in there.
it's got to go in that thing, but notice it's off center.
Yeah. It's
All right, here, let's
it's
put
not in the center.
I'll put this up, hold it up here out of the way so we won't get your finger again. And you put it in, notice there's a flat side on that bolt, so you
Yeah.
just stick it in so that's kind of facing up, and that's it. And I'll tighten it in the back.
Right?
Not quite. Now, how is this going to help?
Wait a minute. That goes straight down on that?
Yeah, right up the middle of it, opposite the end of that screw. Now, how is this going to help?
Wait a minute. This is off center, right?
Mm-hmm.
So that means that when this part comes over here, it's going to be higher than this, right?
Right.
So that's going to push that up.
Right. Look out.
Yeah.
Now, you know what this is called?
No.
This is called a cam.
Cam?
C-A-M. Cam, yes. It's a wheel or a circular device of some kind that's off center.
Oh. You don't need any kind of connecting rod here.
Isn't that nice?
Yeah.
Okay. So far, this is number 3 now, the cam.
Yeah. We've got 2 more.
And I wondered if you know where there's such a thing as a cam that used in your everyday life.
Off center?
Yeah. Well, perhaps you haven't heard of it, but many people have heard of a thing called a camshaft, which is part of an automobile. And you see it? There's one right back there. That thing. You want to bring it up?
Yeah.
Here's a shaft. See it?
Yeah.
And you recognize cams when you see them now?
Yeah, these things.
Yeah.
These are the cans.
Sort of an
because they're-
off-center
They're
crooked
off
wheel.
center. They're all off center.
But notice these are not circles.
No, they're more like eggs.
Yeah, sort of egg-shaped. Well, this is because in a automobile, the cam shaft with the cams would be connected to little things that ride up and down on them because they want to open the valve and allow gas to come in and then close quickly.
Mm-hmm.
Now, let's take a look at this one, for example. Watch what happens because of this peculiar shape. See, now they're closed. The valve would be closed. Now it lifts it open. You see how it would stay open? And now watch what happens when this part goes by. Watch.
drops down
very quickly, doesn't it? You see, so that way you can open and close the valve exactly when you want to. And by spacing these at various intervals, the bump on them at various intervals, you get them to open at various intervals. You see that?
Mm-hmm.
So there's a camshaft opening the valves. Then you probably haven't looked at a sewing machine, but in a toy one anyway, you see if you look down here underneath and see if you can find anything that looks like a cam.
Well, there's one.
Here, take my pencil again so you don't get your fingers down it.
Okay. This part. This circle.
Yes, what does that do?
You see that screw on there is off center.
Yeah.
So when this part of the circle is up here, it's going to push something up.
Notice it moves that plate in the back there.
Yeah.
In fact, watch.
Mm-hmm.
See how it makes it move around? So there's another example of, notice there's circular motion here, but it's transferred to up and down motion, back and forth here. And of course there's several others in here too, because in a sewing machine you want up and down motion rather than circular motion. Okay.
Very handy.
That's how many now?
3.
3. Piston, connecting rod.
Yeah, and the slotted yoke.
Slotted yoke.
And the cam.
Cam. Okay, now we have 2 more to go. This time, I think we'll take that cam off.
Okay. Here, I'll hold this one.
And hold this up. And I'll give you a clue. Here it is. While I'm taking that off, you think about what you could do with those. This, I'll tell you, this one's tricky, so
yeah.
I don't think you'll get it, so don't feel badly if you can't.
I don't know.
Well, one of the things that you're, first of all, you can see because of the construction here that probably goes up here, right?
Yeah, probably.
So put 3 spacers up here. One on top of each one of those screws. And put this up here like that. Okay? Put a wing nut on it. You can put a second one up on the top, on your side up there. 2 is enough, I think.
Get that going.
Okay? Now,
And this, the other one?
in every case where we've had circular motion going in this plane, haven't we? But you could have circular motion going in that plane too, and it'd still be circular, wouldn't it?
Yeah.
Okay, I'll do that. I'll take this, and I'll put this in here like this. Still circular motion now when I turn it around, isn't it?
Yeah.
Okay, now because this is going to go clunking down, would you put that in there and put the thumb screw in the back there? That's a stop. Okay. Now, that comes like that.
Right.
Now look, if I turn this on, you watch what happens there. See that?
It's turning around.
Okay, now, figure out what you're going to do with that.
Well, it's not doing anything over there.
No, but what if
So-
you bring it over here now?
Still nothing. You have to bring it on under here, I guess. Yeah.
What?
Yeah. Put it under here,
Yes.
and this will ride along the track and go up. And then when there isn't any track,
mean like
it'll fall
that?
down. Yeah. And then when it runs out of track, boom. Up.
Well, great. Congratulations.
Thank you.
Now, do you know what that's called?
No.
Well, this is a worm gear.
What?
A worm gear, yes. And this is the rider that's on the worm gear. And, in fact, watch. I'll see if I can make it go a little faster.
Where'd the track go?
Okay, now let's use this to represent all screw-type things, because this is a form of a screw, isn't it?
Yeah. That's
And
right.
where now do we use circular kind of screw-type action to result in a straight line?
A drill.
Drill.
Regular screw.
Regular
This.
screw, yeah, the type when you screw it in. You did it here with all these
Yeah,
thumb nuts. In
that's
fact, I remember that automatic pea packer?
Oh yeah, that's right. That works on the same principle.
Same principle, isn't it? For some reason or other, it's getting stuck. I don't know why. You feel it here? Is it a bump every once in a while? Anyway, notice that I'm turning around, and I could be a motor here, couldn't I? Turning this.
Yes.
And what happens to these threads then? What?
Well, the threads carry the
My little white peas.
yeah, that's right. And when it comes up to here, then it falls back down.
Yeah. So I have a constant supply, but the important thing is here that this could be a method of moving something in a straight line. And do you know where they use such a system?
They use it in a stoker, don't they?
Yes, stokers for coal, and various kinds of assembly lines where they might want to move something along a track, and they don't necessarily have to go up; they can just go straight along. Okay, and then, well, there's an example of circular into straight line. Then you mentioned a drill.
There's a nice hand drill.
Here. You don't have to drill. I just wanted you to make sure that you understood. Circular into straight line, right?
Yep.
And here's
Kind of big.
a little tall for you.
Yeah.
Here's a different kind. That's a little easier to use, perhaps. And I have this one set on a machine, so it'll go slowly, so you see it. You see?
Mhm.
There's the same idea exactly, isn't it? In this case, this would be the worm gear, wouldn't it?
Yeah.
And this would be the part that would be going up or down or whatever. Then there were a couple of others that you probably have used several times, but you've never thought about them. Turn that. See that?
Yeah, closes the.
In fact, this automatic, the automatic P-Packer thread I got from a bigger vise. It's exactly the same system. You see?
Yeah.
Here'd be the P's, wouldn't it?
Mhm.
They'd be moving back
That's
and
right.
forth with that.
All along here.
That's a pretty simple one. Here's one that's a little trickier. Look.
Monkey wrench.
Yes. See, if you look at this, when you turn this, what must happen?
Well, what happens is that these grooves are matched by other grooves.
There's some threads inside there that are probably like a worm gear.
Mm-hmm. And it goes up or down.
Yeah.
But it only goes one way.
Well, you have to reverse the motor. You and I have to reverse it in order to make it go
Yeah.
up the other way. That's right. Yeah. Then here's one that you probably use more often than any other, which you probably didn't even stop to think about. You recognize what that is?
Oh, faucet.
Yes. Well, now, hey, there. See the circular motion that you just went through?
Yeah.
And watch what
down
happens to
there.
the plunger. See, it goes down and shuts off the water.
And then it goes back up.
Yes.
And you turn it on.
So there you have all different kinds of circular motion changed into straight line. So we have 4 now, don't we?
4.
Okay, one more. This is going to be the tough one, too.
Tough.
You want to put that stuff down underneath there while I clean this up? Because this clue is going to be an obvious one. I think you'll get this one without any trouble.
Should I take this off?
Yes, take that one off, too. You want to move this over there?
Yeah.
Right there.
Should I put this under here?
All right, fine. Here's your clue.
Oh, gee. Let's see. This goes on here.
Yeah,
Somehow.
and that goes on there, okay?
Like
Okay,
that.
let's put it on like that. Just put one thumb nut should be enough there.
Yeah.
You put it on just like that. Now what? Obviously this wheel goes on here,
yeah.
right? Oh, wait, no, I took the wrong side off here. Okay. Now what's going to happen?
Well,
You want to put
we
that
have to
through
put
there?
that in.
Yes. Then what happens?
Yes.
Just like that.
Yeah. This is like the worm.
Yes, except this time it's not. It's going around back in that old plane again. What's going to happen now?
Well, these treads match,
Mm-hmm.
and when this is turning, the treads or threads.
Threads, yeah. This is like
pull
a
it
gear,
up. Yeah.
a slotted
But
gear.
then when it comes to a space where there aren't any,
Yes.
it falls down.
Okay, let's see if it'll work.
Mm-hmm.
Okay.
Works.
Oh, I see. Let's see what our trouble is. Wait a minute.
Yeah, we haven't got enough.
No, we got to take that thread out, that screw out in the back. Can't go down
Is
to the
that
bottom.
it?
That's what it is. Has to hit the table. There.
Ah.
Okay.
Mm-hmm.
Now this is a rack and pinion in this case.
Rack and pin.
Rack and pinion. This is the rack, here's the pinion. Whenever you have a wheel going around that has slots in it, and you have a straight line, something or other, or track or something like that going, that could be called a rack and pinion. Actually, it's sort of a rim drive.
Yeah.
Gears and things working on that. Now, can you think of anything around the house that you've used that works on that principle?
A bike.
What do you mean?
The chain.
Oh, the chain, yes. This would be the chain, this would be the gear part, yeah? How about the bike itself when you drive along on the bicycle? Isn't the wheel going around? Aren't you going in a straight line? This could be the bike wheel, and that could be the ground.
Yeah.
In fact, I have some more over here that are more typical of a rack and pinion. Here's one, for example. It came from a drill press. You know what a drill press is?
Yeah, they press things down.
Well, it's a drill in which when you work a handle, the drill comes down and drills a hole in something. See? See? Doesn't that look just like the one we have? Rack and pinion, in effect, yes. Then sometimes they use it on things like cameras. You know, when you try to focus a camera, you have to turn a little wheel and the thing moves up and down. Can you find the two parts?
This and that.
There's the part that goes around, see it? And while you're turning around, this can be going straight back and forth.
Well, what about your finger?
How do you mean?
Like that.
Well, if you did it that way, yes, it would be a thing like that. Here's one that's a kind of reverse. Watch. This is for spinning a top, you see. You see, this is going straight line into circular.
Yeah.
But inside there is a little rack and pinion. And what you're trying to do is to get relatively slow motion here with your finger, in straight line motion, to go into circular motion at high speed. Watch. I want to get a book over here. Just a minute. Then as engineer now that you've passed the test with flying colors, you did all 5 with a little bit of help.
Yeah,
I thought maybe you should see the book that engineers would use if they wanted to solve problems like this and they wanted to get suggestions. Here's a whole book of hundreds, almost thousands of various methods of getting circular and straight line motion and curves and everything, and they could refer to such a book to give them suggestions for how to go about it. And they have lots of other things other than the things we talked about. Notice there were a bunch of springs and various things like that, so that when an engineer wants to solve a problem, he has to determine what's the most efficient way to do it, whether it should be with gears or however you should do it. But he can refer to something like this to do it, and you did very well.
Thank you.
And if you want to, and next time you see one of these, what are you going to call it?
This is a rack and pinion.
That's right. Rack and pinion, and what were the other things we had?
We had
slotted yoke.
Slotted yoke, a cam, a piston, and
a worm gear.
And a worm.
All to make circular motion into straight line.